Jacob wants to scale each of the objects down to make more room in his backpack. Earlier, he used values greater than 1 to scale some objects up with the scale-o-matic machine. Now he wants to set the multiplication dial to the correct setting for each of the objects listed in the table. Jacob needs to shrink the 12-inch long ruler to 3 inches long, and he knows that he will need to multiply by a number less than 1, because if he multiplied by 1, his ruler would stay the same size. He also knows that if he multiplied by a value greater than 1, his ruler would get bigger. Jacob takes 1/2 of 12 inches and gets 6 inches, and that's too large still. So he knows the fraction he needs to use to scale the ruler's length down must be less than 1/2. He just needs to figure out what scaling factor will resize his ruler to exactly 3 inches. Jacob notices that it would take 4 3-inch segments to reach a length of 12 inches. Each segment is 1/4 of the distance to 12 inches. Jacob would need to use a scaling factor of 1/4. He can represent that with the equation 1/4 times 12 inches equals 3 inches. So Jacob needs to set the multiplication dial to 1/4 to scale the 12-inch ruler down to 3 inches. The piccolo is 18 inches long, and Jacob wants to resize it to 6 inches. He knows that he will need to multiply by a value that is less than 1, but he needs to figure out which number will resize his piccolo to exactly 6 inches. On a number line, he can represent an 18-inch length with a green bar. Jacob tries to multiply by 1/2 first, but he finds that 1/2 of 18 inches is 9 inches, so 1/2 is too large and won't scale 18 inches to 6 inches. If he partitions the green tape into equal segments, each segment would be 6 inches long, or 1/3 of the distance to 18 inches. Since he wants his piccolo to be 6 inches long, he can multiply 1/3 times 18 inches. Jacob would need a scaling factor of 1/3. He can use the equation 1/3 times 18 inches equals 6 inches to represent his thinking. The pen is 6 inches, and Jacob needs to resize it to 4 inches long. Jacob knows that the scale factor will be less than 1, but he needs to figure out which number will resize his pen to exactly 4 inches. On this number line, he can represent 6 inches with a green bar and the 4 inches he wants in pink. When he tries to partition the green tape into equal segments, 4 inches long, he finds that he cannot partition it into equal parts, so that won't work. Next, Jacob partitions the 6 inches into 3 equal parts. So each part would be 1/3 of 6 inches. He notices that it would take 2 of the 3 equal parts to measure 4 inches. That must mean that 2/3 of the distance to 6 inches is 4 inches. Since Jacob wants his pen to be 4 inches long, or 2/3 of 6 inches, he can represent that with the equation 2/3 times 6 inches equals 4 inches. Jacob's pencil is 8 inches long, and Jacob needs to decrease its size to 4 inches. So he knows he needs to multiply the 8 inches by a number less than 1. On a number line, he represents the 8 inches using a green bar. He realizes that 1/2 of 8 inches is 4 inches. Jacob can see that he needs to set the scale-o-matic dial to 1/2 as the scaling factor that decreases the pencil length from 8 inches to 4 inches. So he records the equation 1/2 times 8 inches equals 4 inches. When we multiply a value by a number less than 1, the product will be smaller than the other factor. We can use multiplication to scale down.